Welcome, chemistry students. Today, what we're learning about is Lewis structures. We have two learning goals over the next couple sets of lessons. The first one is Lewis structures. Tomorrow, we're going to learn how to predict the nature of a bond here in 5 minutes. Okay, Lewis structures represent chemical compounds. There's two types of chemical compounds that we've learned about, ionic and covalent. We're going to learn how to draw Lewis structures for both those compounds. Ionic compounds, if you recall, contain a metal and a non-metal, okay? Whereas covalent compounds just consist of non-metals. So remember, it's going to represent bonding. Now, atoms want to have full shells. They want to be stable. And we can do this several different ways. For ionic compounds, we have a metal and a nonmetal. So that means you have, essentially, I want you to think of metals because they lose electrons, and nonmetals because they really like electrons. Metals are weaklings, and nonmetals are bullies. Remember, metals want to give up their electrons to the nonmetals. So we can show this a couple different ways. But if you take a look, this electron is going to take a path to this chlorine. They're going to achieve each other's octets. Remember, sodium has several shells, so if you remove this electron, it has a full shell. Remember that this is stealing an electron, so now what we have is sodium has lost its electron, so therefore has a positive charge. Chlorine now has a negative charge. We put square brackets around this whole thing to represent that whole thing has a negative charge. Now overall, this ionic compound, NaCl, is neutral. The chemical formula is NaCl. It is a neutral, it is stable, but it is made up of ions, hence it is an ionic compound. This is how you draw Lewis structures for ionic compounds. Here we have the Lewis dot diagram of two nonmetals for a covalent compound, hydrogen and carbon. Remember, hydrogen is happy with 2 electrons, so in a covalent compound we draw bubbles around them, and this represents a chemical bond. They are now sharing this electron. Hydrogen now thinks it has 2, even though carbon still owns this electron. They're sharing the 2, and it is a covalent bond. Now, hydrogen is happy, but you can see carbon it wants to have 8. It does not have 8 in this scenario, so it actually makes a few more bonds with some more hydrogens, like so. So again, when we have nonmetals, we share our electrons. Let's take a look at it. And carbon now has 2, 4, 6, and 8 electrons. It has the octet. It has a full shell. Hydrogen, each hydrogen has 2, also a full shell, because it's just the first shell. Let's clean up the Lewis dot diagram so it looks a little bit better to you. So our diagram is now cleaned up a little bit. That is CH4. The chemical formula for this compound is actually CH4. 1 carbon goes with 4 hydrogens, and it's stable. Our ionic example, our chemical formula, is NaCl, and that is stable as well. Now, we're going to refer to this diagram as something called the Lewis dot diagram, okay? And the Lewis structure diagram is technically going to be the diagram here. Now, to do the Lewis structure diagram, you have to show the ions for the ionic compound. And for the covalent compound, what we're going to do is we're going to replace these bubbles and dots with lines. Take a look. Remember, each one of these lines represents 2 electrons. Carbon has 8. Everybody's achieved the octets in both examples. This is the difference between covalent and ionic examples. Let's look at one more complicated example for ionic and maybe one for covalent really quickly. This is probably the most complicated example you can do for an ionic compound. It's between calcium and phosphorus. So we start by writing the atoms as Lewis dot diagrams. Calcium has 2 dots, phosphorus has 5. Calcium is a metal, so therefore it transfers its electrons to the nonmetal. You can see that calcium is now satisfied, phosphorus is not, so we need to add another calcium. We now add another calcium, and it transfers to finish off the phosphorus, but this calcium is unstable. Therefore, we need to give this electron to somebody, so we have to add another phosphorus. We now can give away this electron from calcium, But as you can see, we still have 2 empty spots, so we have to add another calcium to do the transfer. Now, as you can see, everybody has achieved the octet. This is the Lewis dot diagram. Let's look at the Lewis structure diagram. So as you can tell, calcium has given up 2 electrons each, so that gets a 2 plus charge, and phosphorus gained those 3 electrons from each one of those calcium, so it has a 3 negative charge. So the Lewis structure will look like this. There will be 2 calciums, and there will be 3 calciums and 2 phosphorus. This is the Lewis structure right here. Put it aside so you can see it a little bit better. That is it right there. That's the end of the lesson. Please do me a favor and draw the Lewis structure for our covalent compound CO2. Bring it to class tomorrow, and remember, this should be covalent. You should show me bubbles to do the dot diagram, and then show me the structure. So